Page 89? 80. So number 60, okay. Oh. So there's kind of two obstacles. There's two main parts to this problem. One of it is not that big of a deal, hopefully. They have plus a negative, right? That should not really bother us too much.
So you cross cancel the fourth, right?
What's that bar mean in the fraction? What operation?
Minus.
Division?
Division. What's the only time division can be canceled? When you're doing what operation?
Multiplying.
Am I multiplying?
Don't you have to flip them, maybe?
Am I dividing?
Well, if
I'm adding. So nothing can cancel, because addition is not the opposite of division. Cool? It's very human to go, there's a 4 there and it's there, it's going to be so easy if it just, of course it's easy because it's wrong. Right? You can only cancel when you have opposite operations. Think about that. On the surface that is very simple. Division cancels multiplication, and the other way around. Addition cancels subtraction, and the other way around. Here, I don't have opposite operations. I have addition of a negative, sure, but it's addition, and I have division. Those can't go well together, right? So how do you take care of the plus and negative? Do I really need that? Plus and negative, how can I rewrite that?
You change it, right?
Okay, good. Change it in what way?
Make it a negative.
I like it. So you guys cool with that? Those are the same thing? Adding a negative is really subtracting. If you add more debt to me, are you not taking more money away from me? You're subtracting money from me if you add debt. So adding a negative is the same thing as subtracting. And now how do you subtract fractions? And in this case,
Should be 1/9. So negative 1/9.
not quite, because you need
Common
common denominator.
So it's 4 times 9, 9 times.
I love it.
36.
Because the 4 and 9, I love it. The only time the common denominator is this times that is if they don't have anything in common, right? 9 and 4 have nothing in common. So this is missing a 4 and that's missing a 9.
16 and 16 and then the negative. Okay.
Cool. All right, you give each one what they're missing. How are we doing so far?
Good.
Okay, cool. So of course I'm overstating this problem in case somebody needs this kind of help with their fractions, which could happen. This problem, on the surface, it really shouldn't take this long, but I'm kind of like making sure everybody understands every little thing I'm doing, right? Fractions, I'm adding a negative, which I can make a subtraction. The only way to subtract fractions is to have like denominator, like terms. And there's my LCD is going to be 36, yeah. Go ahead.
If they don't have, say for example, they do have a lowest common denominator, but you just can't think of it, say it's a big one or whatever, can you still do that?
Oh yeah.
And
I mean,
they'll just
technically,
make
I'm
it
not
up,
going to
right?
take any points off unless I specifically say use the LCD. But for example, what you're thinking of is if I had 1/8 plus 1 24th or something, and you multiply this one by 24 and this one by 8. Do you guys see how that would work? They would both have a 24 times 8 on the bottom then? Is that the LCD? No, that's just a CD, right? It's just a common denominator, not the lowest. Will it still work? Of course. You just got really big numbers that you have to reduce at the end. Will it still work? Hell yes. LCD is just to help us not have to reduce so much and not have such huge numbers to work with, right? How we doing? Yeah.
So the property there would be finding the lowest common denominator?
Not really a property, but it's a requirement for adding, subtracting fractions. They have to be like terms. Here I've got 4/9 and -5/4. I got 4 something plus -5 is something else. They're not like terms. Now I've got 16/36 minus 45/36. Now they're like terms. Right, 16 of these minus 45 of these is negative 29 because the bigger one's negative. Cool. Can I reduce that? Well, 29 is What kind of number is 29? Prime. So obviously, ain't nothing I can do with that unless 29 goes into 36, and it does not. How's that? Is that decent?
Just leave it alone.
Yeah, exactly. Just leave it alone. We did enough stuff to it. Cool. Any other questions from the homework? Yeah.
106.
The one with the 5, 6 in there?
Yeah.
Okay. This will be useful. All right, sweet.
Is it supposed to be towards you or the board?
Wherever I'm writing at the moment. So I think I'm gonna write over there. I need to hire a cameraman. So let's see. It says I've completely forgot which one you wanted to do. Which one was I? 106. 5/6 of the sum. Okay, this is an evil one. And let me show you why it's evil. How do I do like 5/6 of 12? How would you write that? How would you write that mathematically?
Multiply it.
Beautiful, because we talked the other day about of means multiply. So it'll be 5/6 of the number 12, and then you could do that.
So you have 12 over 1, that is the same.
I like it. And now what can I do that I couldn't do over there?
And then you cross cancel.
Because this operation is what?
Multiplication.
Multiplication, then that will cancel the division. I love it. You guys see that? 6 goes into 12 twice. 5 times 2, 10. So now you're back there saying, okay, you solved a different problem, thanks a lot. So let's look at the actual problem. 5/6 of the sum of 12 and negative 6. So what am I taking 5/6 of means?
Multiplication.
Multiply 5/6, and what do I put in here? The sum of 12 and 8. So you can put 12 plus negative 6, or you can go straight to the point. Right? Is that cool? Just to make sure you guys, there's the direct translation, right? The sum of 12 and negative 6. And what am I going to do to that sum? I'm going to take 5/6 of that sum. So why is it wrong to write that? Because this says the 5/6 of 12 added to that. No, that's not what it says. It says take the 5/6 of the sum, and then inside here you put the sum. Cool. So do you see how, when you're translating this stuff, 5/6 of what? I got to multiply those things together. So what two things I have to multiply together? 5/6 times the sum of 12 and 8. I got to put that together because I have to figure that out first. And now solving this shouldn't be too evil. Right? What's 12 plus negative 6? 6. And the 6 is
Cancel.
cancel. Yes, sir.
I thought you would just multiply straight across.
You could.
Oh, but then you get 30 over.
You get the same thing because either you kill the 6 first and you get a 1 here, right? And multiply, or you multiply 30 over 6 and then you kill the 6's and you get 5 at the end anyway. Right, 30 divided by 6, 5.
Can you remind me the rule when you cross multiply?
The only time that you can cross multiply without being really creative. There are other places you can cross multiply, but you really got to understand what the hell you're doing. The only place you can officially cross multiply is when you have an equation with a fraction equals a fraction.
Okay. Yes, that was not a cross multiply.
Definitely not. No cross multiply because it is a multiplication problem. Multiplication problem. This is not a multiplication problem, is it? Right? You guys, this is not a multiplication problem. But the shortcut is cross multiply. That's where people get confused. You hear the word multiply in there and you think, oh, when I multiply, I cross multiply. No, you multiply when you multiply. Here, what would you do to kill, and this doesn't really make the most sense here, but if you didn't want any fractions, what would you multiply to get rid of the 6?
6.
And see how it cancels out there? And it moved up there?
What do you do after that?
And then how do you kill this x?
Times 6.
Multiply both sides by x. And it cancels out there. So what happened to the x? Where did it end up? It went up there. Interesting. What happened to the 6? It went up there. So the shortcut is cross multiply. We forget that connection. That's why cross multiplication works. It's a shortcut to solving this kind of equation. But then we think cross multiply. Everywhere I see a fraction, I'm going to try to no. It only applies here. This is how it was created. Just like this. And of course, just to finish this out, 5x equals 42. The last step there is divide by 5. I like it. And you get whatever that. You can do that, or you can do 8 2/5. Right. You don't have to make it this unless the directions say to.
How would the directions tell you to do that?
Leave your answer as a mixed number. Right. This is improper fraction because it's top heavy. There's your mixed number because it's got a whole number and a fraction. It's mixed, yeah. Cool. Okay. Yeah.
Number 2.
Number 2? On the review?
On page 83.
83. Now, sometimes I would say you should try to find an LCD for all 3. This is a case where that might not be the best way. There's 2 different ways to go at this. These 2 have a nice LCD. These 2 have a nice LCD. These 2 don't play well together. You guys see that? 8 and 15, do they have anything in common? So I have to multiply this by 15 and this by 8, and then I have to somehow bring 12 into the mix. Screw that. Let's do one of them at a time, right? And what I mean by that, I mean this pair, and then we'll do that at the end. So how do you find the LCD between these 2?
4.
4 is the number they both have in common, the highest number, right? 8 is 4 times 2, 12 is 4 times 3.
24 works.
24 works, exactly. So you can either break them down like this. You see 4 is the biggest thing they have in common. So what does he need that he's got? Do you see that? What does he got right now? A 4 and a 2. What does he got? A 4 and a 3. So what's he need? He needs a 3. And what does he need? A 2. And wouldn't that make them both 24 then? Okay, maybe. So that's not a bad way. If you can't figure out looking at the numbers that it's going to be 24, you can think, what's the biggest number they have in common? In this case, it's 4. Whatever else they have must be what the other guy doesn't have, right? If I separated what they have in common, the other crap is stuff they don't each have. So he's got a 2, he's got a 3, so he needs a 3, right? And he needs a 2. So what do I end up with in the end? I have 15 over 24 plus 22 over 24. I still got my 7/15 over there, right? Cool. So then I get 37 over 24 plus 7/15.
Is that the answer?
Have I finished simplifying? No, because I still have an addition to do, right? Now here's where it's ugly yet not so bad. Do either one of these reduce?
Yes.
No.
37 is what kind of number? Prime. Yeah, good. No. But do the same thing I just did up here. What's the biggest number they both have in common? Think about it. 3. This 24 is 3 times 8. 15 is 3 times 5. So they both have a 3. He's got an 8, he's got a 5, so what does he need?
A 5.
A 5. I love it. You guys see that? Let me do this with, I think I have one more color. Alright. I really desperately want you guys to see this because so many people have so fundamental problems with fractions, but they're really not that bad. The whole idea is making the bottom the same. And people say, oh, it's really not easy to do. No, it's easy. You take out the part they already have in common. They both have a 3 already. So do I need to worry about that? No, that's the same already. He's got an 8, so he needs an 8. He's got a 5, so he needs a 5. They become big, ugly numbers, but at least I'm done with getting the LCD, right? So I get 37 times 5.
185.
185, good. 24 times 5. 120. 7 times 8. 56. 15 times 8, just to double check. It should be 120. And thank God it is. If you do 15 times 8, you get 120. How we doing? And again, because it's very often we get mixed up with how to get somewhere. Just think, I know where I want to be. I want to have the same denominator. So I'm hoping that kind of helps you remember this process. If you ever have trouble figuring out what the LCD is, you could just break it down. What do they have in common, the 3 in this case? Then give the other guy the stuff he's missing. It's that simple. It's all. If you need 2 people to have the same thing, you look, well, what do you got? And what do you got? Well, you got one of these. Let me give you one of those, and you got. Let me give you. And now you both got the same thing. It's the same idea. It's exactly the same idea. Cool.
So this is the process.
This is the process.
When you got
This is my suggestion. If you have trouble, often you don't need this. Some of you guys could see this 24 without doing this, right? You guys could figure it out. 8, 16, 24. Oh, cool. But 24 and 15, now that's a little bit harder to kind of get at. So this process makes it a little easier, possibly. It's up to you, though. You don't have to do it this way.
No, that makes sense.
Cool. If you like this way, do it this way. If you have another way that works, do it that way. If you don't have any way that works, come see me.
Exactly. I don't have any way to work, so.
Shoot.
Other than this, now.
Oh, well, there you go. So you're good.
Yeah.
And now the last step here, or maybe the last step, unless it can reduce. What do you want to add those together?
241 over 1.
I like it. 241 over 120. And that almost reduces. If that would have been a 240,
It would have been really good.
240 over 120 is 2. I love it. So it's 1/120th more, so you could write it like this if you wanted to. Either way. Either way is right. Yeah.
I got with the way most of the way by 12 by 15 and divide by 2.
12 and 15?
Most of the all of them, 8 by 12.
Oh, I see. Yeah, yeah. No, that'll work too.
Divide by 2.
Divide by 2.
Yeah. After.
Oh, I see, because 8 and 12, they have a 2 in common. That'll still work. That'll still work. So you figure out your LCD by doing 8 times 12 times 15 divided by 2.
Divide
I like it. So your LCD was actually
by
360? Okay, good. And at the end, you just had to reduce it down to 120 at the bottom.
Yeah.
I love it. So, do you guys start to understand this? It's almost bad that there's more than one way to do stuff in mathematics, because then people start doing half of one way and half the other way, and that don't
Yes.
work.
That's my problem.
I understand. So you pick a way that makes sense, and you stick with that way, right?
Okay.
So the way you did it was, you kind of made an LCD based on all 3 of them, and you reduced it a little bit, and at the end you went, oh, I could reduce it even more. Nothing wrong with that. Unless they specifically said use the LCD. Now I'd rather see some thought like this instead of just multiplying all of them together. So I like the fact that you cut it in half. You kind of figured out, I don't need it, 720, I can make it 360. Okay, yeah.
For example, right there, the 24 and the 15. Yeah, right there. For example, 3 goes into 24 8 times, so, and then the 3 and the 5 goes 5 times. So can you put 37 over 8, and then 37 over 5?
I see, I see. So you're saying right here, you're saying that since 24 is 3 times 8, and 15 is 3 times 5, now tell me how those 3's cancel exactly. I understand why you think that way, because they both have a 3, so why do I need it? No, they both have a 3, so why should I give it to them? But how can you take it away? In which case, you're saying that 7/15 equals 7/5. Is that true? No, so you can't do that. This 3 being on the bottom, what does that mean it's doing? What's the operation? Since it's on the bottom, the 3 is doing what? Dividing. Do I have multiplication in here? No, it's got an addition. So there's in fact, they're both on the bottom. So there's no way for those to just cancel out. Do you see that?
You can only do that on multiplication and division.
Exactly. If I had 3 times 7 over 15, and then you can break the bottom up into 3 times 5, now the 3's go out. Why? Why can I cancel here?
Multiplying the top.
Yeah, multiplying cancels division. It's that simple. I really want you guys to understand. Math isn't just throw some numbers down and pray. It's not the lottery. The rules make sense. You can only cancel things out if you're doing opposite operations. Think about that. Some of you guys got some homework back. I already said on some of the homework, multiplication does not cancel subtraction, or addition does not cancel division. It's the easiest mistake to make. You see something like this, 5x equals 10. The next step I see is this. What did they do wrong?
They're not like
Yeah, I like that. These are not like terms for one thing. What's 5x minus 5? 5x minus 5. Can't do anything with it. But the more direct thing is, what's the operation here? 5x is multiplication, right? So how can subtraction kill that 5? Subtraction can't kill multiplication. Division kills multiplication. So the right way to do that problem, of course, is to divide. Then they cancel out. You guys see that? Some of the most common and easy mistakes to make is that kind of mistake right there. Yeah.
Oh, what will happen if you check the 8 and 12 and 15 and multiply them together?
That would work. That's almost what the guy in the back did.
Oh, and then divide your answer by 8.
Now if you do 8 times 12 times 15, division by 8 at the end won't really do too much for you because they don't all have an 8 in common. At the end you might end up with something that can be divided by 8.
Oh yeah.
Okay.
Because when I was doing mine, I got like 1,440.
Gotcha.
And then
And then it reduces.
And then I divided by 8 and multiplied by 5.
Oh, you mean because of these?
Yeah.
Oh. You can only multiply by a reciprocal when you have a problem like this. Let me show you 2 things to your question, really. Let me do it here, actually. 2 parts to your question. The first part of your question was, could you just multiply 8 times 12 times 15? Yes. But then, for example, what would he be missing if it's 8, 12, 15? He's missing 12 and 15. That sort of sucks, right? But it still works. You can give him a 12 and a 15. You can give him a 8 and a 15. Oops. Crazy shit. And this one needs an 8 and a 12, right? Now what's kind of wrong? This would still work. It's not an LCD. Huh?
Oh, it's complicated.
Exactly. It kind of gets loaded with big numbers, right? That's why LCD is so discussed, because it makes everything as small as it could be. You don't have to work with such huge quantities.
I don't do it like this.
No, I know. You divided by 2.
360, I divided by 8, so how much will I like? I multiply 5 by this number. So 360 on 8.
You're right. You're good. So you kind of reduced it and then reduced at the very end. You're fine. You still didn't have really an LCD, but you didn't have it nearly as bad as this. So you're fine.
Any number to other than 360 for 3 of them at the same time?
You could, sure.
As well?
At the heart of this, what do you need to be able to add fractions? The bottoms have to be the same. What's the easiest way to add fractions is to find the LCD. You guys kind of with me? The LCD has uses that go beyond this problem. That's why we teach you LCD, for 2 reasons. Number 1, it makes the number smaller, and number 2, we have a reason for it later. This problem, if you did this, which is even worse than what you did, right? I'm not saying it's bad what you did, I'm just saying it becomes kind of really big numbers. this would work. Because at the end, it would just all kind of reduce out to be this. It'd be a huge, ugly number, and it reduces to be this. Yeah, sorry, you've been waiting for a while.
How would you go about ordering them, like multiplying the 12? If you were to go the long way and 12 times 15 times 5 and all that good stuff, how would you go about ordering that? Like, does 12,
Here?
Yeah, like, do you multiply 12 times 8 then 15, or
Oh.
like, how would you go about
How do you?
ordering it?
Is there a way? Is there a way you can multiply things? No. 2 times 3 times 4. You could do 6 times 4, which is 24. You could do 2 times 12, which is 24. You could do 8 times 3, which is 24.
Okay, so
We know that you can multiply whatever order you want to. So it doesn't matter. You just multiply these however you want to and see what it comes out to be. Yeah.
So if you go back to number 2, just for my own clarification, the reason why we're not multiplying by 3 and 4 on each side is because there's both can divide by, or I'm sorry, the reason why we're not multiplying both sides by 3 is because they can divide by 3 once you multiply them.
And let me be more specific. Let me do this again. The first step here. So we decided to only look at these two, right? The biggest number 8 and 12 have in common is the 4. So then if you break it up according to 4, you can see what they don't have. They both have a 4. This guy has a 2, and this guy has a 3. So to make them have the same stuff, like I think of 2 brothers, about 6 years old, and they're looking at each other. He's got chocolate chips in his. He's got sprinkles in his. Like, shut up! Here's your sprinkles. Now you both have the same shit. Leave me alone, right? You with me? I don't have kids. I'm not sure why I come up with that example. They're normally sitting next to that family. But see, it's the same thing. They both have a 4. They both have a bowl of ice cream. This guy's got the chips, the chocolate chips. This guy's got the sprinkles. Like, shut up! Just go and get it. So you just give the guy missing the chips, you give him the sprinkle, give him the chips, you give the other one the sprinkles. So what's he need? He's missing a 3. So you give it to him. What's he need? 2. And then of course you end up with 2 times 12, 24, 3 times 8, 24. They both have the same. Of course they do, because you gave each of them what they were missing. So they end up being the same. How we doing? Yeah, and then I'll come over here.
Well, are we ready to move from this one to another one, or?
I so am.
Okay,
I wouldn't mind. But did you have a question on this one?
Oh, no.
Okay, go ahead.
I have 2 quick questions about 2 problems, and then I have 1 full question about a problem.
All right.
For 132, it says a number multiplied by 8
Oh, sure. Just a second.
added to the.
Oh, just a second. Before we get to another one, there's one more.
My question was, okay, you got 24 in one denominator and then 15 in one, multiply that. And what about, so you get the lowest common denominator. And then you take the, what was, the numerator that, why can't you cross multiply?
Cross multiply. Mean like at this step?
Yes. So you got, multiply that, you have 24 times 15.
Oh.
And then multiply that times the other way.
That is what you could do here. And again, like I said, 24 here to 15 there would be a common denominator. It wouldn't be the lowest common denominator. It will still work. You'll just get bigger numbers than you really need. So I really want to be careful. Very often I'll do stuff on the board.
Plus the positive sign is hidden. So you just multiply that, you just cross multiply it, because the addition is hidden.
So there's no real cross multiplying. No real cross multiplying here. Yeah.
Right, yes.
Okay, good. Alright, so.
Okay, I just wanted to know if they're talking about the same variable, if they want you to use the same variable or two different.
Which one was it? I'm sorry.
For 132.
132.
It says the number, but.
I like it. So they set up a number. So if you call the number X, you have to use X everywhere they refer to it.
So when they say the. it's
Exactly.
the same
The
one?
number means that same number. If they said a different number, then you use Y or something else.
Okay.
Cool.
I have.
Oh, that's right.
For number 134, after I did all of that, and I was trying to subtract two fractions, does it matter which fraction is before? If the lower fraction comes first, would your answer be negative, or can you change them?
When you make the bottoms the same,
Yeah. the
you can
bottom.
just look at the tops, right? So on one top, you'll have, what is it? 9 minus 10, right?
Yeah, yeah.
So 10 is the bigger number.
So you can.
The bottom's the
number-
same, so it just kind of comes for the ride.
It doesn't, it's not a negative?
Number 134. So number 134, once you do the LCD, you get this. So 9 somethings minus 10 somethings is -1 of that
Okay,
thing.
so you have to keep it in that order. Okay. And.
Exactly, because 9 minus 10 is different from 10 minus
Yeah.
9. Cool.
Okay, my last problem is number 138. I need a better method to do that in case there's a problem with when the exponent is high.
Is that one? Negative. When you square a negative, what happens to your answer? Positive. So you can pretty much forget that, right? That's not a part of the problem anymore. What do you still have to square? 5 and 6. What's 5 squared? 25. What's 6 squared? There you go. So you really do not have to write it like this. That's why it works, right? Because -5 times -5 is 25. 6 times 6 is 36. But you know what 5 squared is. You know what 6 squared is, or you should. So you don't have to write it out like this. Just do the square.
So for other problems with exponents, you do the exponents separately for the numerator and the denominator?
Yes, because what you actually are doing is you're realizing, well, I wish I would have done. You're realizing that if this is the case, isn't 5 times 5 5 squared? 6 times 6 is 6 squared. So the shortcut is the square just goes to both.
So this is.
Because what do you have to square? The 5 and the 6. Sweet. So it's called power distribution, right? A lot like the distribution property.
And you're not reducing X, you can't, right? The 25 over 26 is.
I love it. I know I can't. I can't reduce this. So I should not be able to reduce the end either. They're not. This has 2 5s. This has 2 6s.
And that's the answer. We're done.
That's it. Yeah.
Can you actually do 132?
Oh, did I finish it though? Where'd it go? I went way off on a tangent here. Did I never do that problem?
No.
Oh yeah, I
I
did.
never did it.
Oh,
Oh, you just answered for a question on that, but you didn't do it.
132.
Yeah.
I don't think I talked about 132.
What page are you on?
I'm on page 82. Is that the one? A number multiplied by 8?
Yeah.
Okay. I haven't talked about that one yet at all. I don't think. So, oh, I'm sorry. Yeah, I did. It was really quick though, just the number thing. So a number multiplied by 8. How do you write that? A number multiplied by 8. Good. You could write this, but why does that kind of bother us?
Because you want to need super.
Because where should the 8 be? Yeah, it's like a coefficient. So here's a number multiplied by 8. Added to the sum plus the sum of what? 5 and 4 times the number. So what two things have to happen here? Adding to the sum of 5 and 4 times the number. So that one had a few different creative ways of putting that together. But you guys see how this something added to the sum of two things, and then just identify when they say the sum of blah and blah, blah and blah. That's how you break it down. You have to figure out what those two things you are summing, what those two things are you're adding. I'm adding 5 and 4 times the number.
When it has you
Just right now, like that we're rewriting out, do you want us to answer it too?
Yeah, it says, and combine like terms when possible. So then that's just straight up translating from Mathish to English, from English to Mathish. Now, what like terms do you have?
The X.
8x.
Plus 4X.
What's it doing? What's the operation?
Multiplication.
What's the operation?
Addition.
Addition. So 8x plus 5, can I put those together?
No.
Plus 4x, can I put those together?
Yeah.
What's 8x plus 4x? And what do I still have there? Not going to do 17x?
No.
No.
Why not?
Because it's not the same X.
They're not like terms. I don't have 17 x's up there. I have 12 x's and a 5. If you write this, you're telling me, yeah, 17 x's. Well, why isn't there? 17 x's. And I'm like, wow. You don't have 17 x's.
The 12X plus 5 is the 5.
That's it. You cannot say you have 17 x's because I have 12 x's plus 5. I don't have 17 x's then, do I? These are not like terms.
Say for example, that was multiplication, 8x times 4x is 32x squared, or?
That's right.
Oh, okay.
If it was multiplication, you have to like distribute it, and then you get an x squared. X times x is x squared. So it's a little bit ahead of where we want to be. So they wouldn't do that to you. Yeah.
Can you do number 60 on
All right.
page 91?
And then this is the last question.
We did 60 when we
90?
91.
Number 60.
And also for over
Oh, did we do that one?
Oh, we did?
Maybe.
Oh, we're doing that.
Last class?
No, I don't think we did this one.
Okay. I got stuck on
This is from the next homework, not the one that's.
Section 2.1. This is page 91. All right, now this looks
Awful.
disgusting. There's something really nice about your variable terms.
They're little.
They're the same.
They have the same
No.
denominator, right? And you want to put them together eventually. First thing I can do though, what do I really do first? Is there any like terms over here?
No.
Not yet, but there are like terms in the sense that there are two numbers there.
It just needs common denominator.
Exactly. So these two I could put together.
30?
Yeah, 30 will be the LCD. There's nothing in common 5 and 6, so you multiply them and get the LCD. That's the only time it'd be an LCD by multiplying is if they have nothing in common already. So you multiply him by 6 and her by 5. I don't know if they're him. So what do you get here?
24.
24 over 30 plus 5 over 30. 24 over 30 plus 5 over 30 is
29.
now how do you get your s's together? Your variables, they have to be on the same side, right?
Add 1/7.
Yeah, so this is minus 1/7 s. So you're going to add 1/7 s to both sides. Do you notice how it doesn't matter there's fractions in there? The steps of solving equations cannot change. All that can change is the players. They have any fractions in there. Oh well, you do the same thing. You get them together. Yeah.
So just because when you add 1/7, it's going to become 7 over 7. Could you just leave it as s? Because
I
it's
love
one
it.
s.
6/7 plus 1/7 is a whole
Mhm.
s, right? So that'll be a whole s. Is that cool? Because you get 7 over 7, which is 1. Minus 3/4 equals 29 over 30. Thank you. I couldn't go much further. And now, one last step and you're done.
Add 3/4.
Add 3/4.
You have to do a common denominator first. Or?
Yep. And this might be related to what you're saying. If you do 4 times 30, you've done too much. They already have a 2 in common. So you can divide out what they had in common. 4 times 30 is 120, divided by 2 is 60.
Should be 120 in the denominator there?
That's too high, actually. And it would work.
Okay.
It would work. Don't get me wrong, but it just wouldn't be an LCD. I wouldn't take any points off if you made the LCD, the common denominator 120, but the lowest common denominator is 60. Okay, how we doing? Right, so to make this an LCD, you multiply by 2 over 2, and you multiply this by 15 over 15 to make 60. Uh-oh, now we're in trouble. And again, let me show you the way that I was doing it earlier. Isn't this, what's the biggest number they have in common? 30 and 4. 2. 2 times 15, and this is 3 over 2 times 2. So isn't he missing a 2? And he's missing a 15. There you go. So I rewrote it. 30 is 2 times 15. 4 is 2 times 2. So he's got a couple 2s, so he's missing a 2, right? He's got a 15, so he's missing that 15. So now what do they both have on the bottom? 2 times 15 is 30, times 2 is 60. Let's see, up here we get 58 over 60, and this will be 45 over 60.
And then you just add those two?
Just add those two, cool. 58 plus 45. Something or other. 103.
103.
Beautiful. Yep.
So, how did, I get that you added the 3/4 to the 29/3, I just don't see how the fifth, where you're doing the 215 times 2.
The LCD here is 60.
Yeah.
So you multiply him by 2 to make it 60. You multiply him by 15 to make it 60.
Yeah, that makes it 2 opposite.
It gives each one what the other guy's got, what they're missing. Cool. If you did 120, it would still work. You just have to reduce it at the end. It would still work. Okay, maybe. All right. So, on Wednesday, there will be a quiz on chapter 1 through section 2.3. What?
I have a question.
Yes.
Grades, are they on your website or no? Do you post them?
No.
Every now?
Nope, never. So just come see me if you want to see what your grade is. After the second test, I give you a whole sheet of a summary of grades and the homework I think I'm missing.
But you always have them with you? If we wanted to ask on your break or something like that?
Not with me always, no.
Oh.
It's in my office.
Like email?
Sure, email works.
Okay.
Okay. Not a big believer in, believe it or not, in a lot of online Blackboard and micrograde or whatever the hell. Okay, any other questions about anything? So what's going to be in that quiz? What I normally do with quizzes is I make them very, very basic and to the point. So it'll be chapter 1 questions, which should be review. And then there'll be some solving equations with no trick questions. There's not going to be any that are no solution or all real numbers. It'll be very basic solving equations. And make sure you guys can do the right thing. So no big giant equations, just some straight to the point equations. No word problems yet because we're about to do that. Okay. So any other questions before we get into the new stuff? How's this guy doing? Good. Okay, wow. So, I know, of course, since I teach math, now if I ask you what your worst dreaded part of mathematics is, word problems, if it's not number 1, it's close, right? Fractions are up there, graphing is up there, word problems is always up there for everybody, right? And I understand, because math is a foreign language. So you are translating from English into another language. And it's just like Spanish or French or something. If you start really trying to learn it later, you're not going to have as firm of a grasp on it as if you would have been learning it from when you're 2, right? So none of us started learning algebra when we were 2, so we're all going to have some trouble. So I'm going to try to show you the ways that should work. And a lot of what I'm going to tell you is going to be a suggestion, but those of you who actually do it will have a much easier time with word problems. So let's do this. I'm going to intro the 2-4. We're going to do a little handout. I think I'll do the 2-4. We'll take a break, and then we'll do the handout, and then we'll finish up 2-4. I think that's my plan for the day. All right, here we go. So let me start us off not too evil. Let me see now. Let me do. Don't say this out loud. How old are you? Oh, okay. All right. So, if I said, what's your name? Luis. Okay. So I got Luis and Jeff. If you add their ages, you get 59. So Luis actually already could figure out the answer because he's part of the problem, so he knows the answer. That by itself, is that enough information to really figure out anything?
No.
Unless you know Luis and you know how old he is? Even if you try to guess, you might not be right. So how old could we be? If he was 24, how old would I be?
30-something.
30-something, I like it. 35, cool? And so forth. Obviously, he's not 2 years old, so I can't be 57, thankfully. Actually, 57, I wouldn't mind. Anyway, you need more information from me.
He's taking notes for him. He's being really sweet, and he's part of your equation, but he needs to do like that.
Oh, okay.
So much.
Cool.
Sorry.
That's all right. So we have 2 players here. So the first step in a word problem, the reason that so many people do poorly with word problems is you guys, I think you think you're supposed to be able to get the equation when you first read it, or you just want it over. Get this homework over. Let me write something down that's got all the numbers in it and get something. You never know, maybe I'm lucky, right? But really, the first step in a word problem is not mathematical at all. The first step is just how many and who are the players in your problem. I've got obviously 2 players, Luis and me, right? So if I told you some more information, Jeff is 39 years older. No, he's not. Jeff is 19 years older than, I think I might just give him some away. Too bad. Pretend like that didn't happen. So here's how you do this, and trust me, the people that don't do what I'm about to do are the people that are going to make the most mistakes. Some of you guys are probably good enough with this stuff in your head, you don't have to do everything I do. I understand that. If you're not that confident, you should do everything up here that I'm doing. The first step, you don't care about the numbers, you don't care about older, less than, all that kind of shit, twice this and all that stuff. Forget that. Blah, blah, blah. 2 things. And actually, it's our age, right? 2 things involved here are ages. Which one of these things would I really have to know first to be able to figure out the other one? I'm 19 years older than he is. So I'd have to know his age first, and then I could do what to figure out my age? Add 19. So see how Jeff is blah Luis, right? So then I have to know Luis first. So what do I call? Do I know what he is? How old he is? I do, but do you guys know? No. So what do you put down there when you don't know? X. Now, the reason we do that is because If I didn't give it a math name, I couldn't give this one a math name, and then I couldn't make an equation out of it. So this is what I'm mean by you're translating from math to from English to math in this case. What's my age then based on that?
Plus 19.
Beautiful. Him plus 19.
Equals 59.
Now, what equals 59? Be careful. The biggest mistake I get is somebody says this. What's wrong with that? What is x plus 19 in English? That's mathish for who? So you're saying I am 59. Thank you so much. So you say that's a mistake.
Yeah.
What do I do to get 59?
2x.
Add those. So I think part of it is some of you guys don't even write this down, and you just see the 19 years older. So you say, okay, there's the 19 years older. There's the thing it's supposed to be. You get an answer, and you're wrong. Because you didn't do this. Add their ages. How old is Lewis? X. How old am I? X plus 19. So x plus x plus 19 is 59. There's the equation, right? I gave him a math name and me a math name. What are you supposed to do with those two things? Add them up to get 59. Now this should be the easy step. Solving the equation. And we'll see if I heard you correctly. So what's your first step here? This should be the easy part. I like it. Good. 2x equals 40. So x is 20. Now do you see why that's not a good place to stop? Because how many people's ages do I have in this problem? And you've only given me, in fact you haven't given me an age, you said 20. And I'm like, well, I asked you for 2 ages here. I want to know how old we both are, right? So who's 20? Of course. I passed 20 a while back. And how old am I?
20 plus 9.
39. I heard you correctly, right? Yeah. Okay. Do you guys see that? Maybe. So your first step in a word problem is never math. Your first step is English. Your first step is write the parts of the problem down, the names. What is it in English I'm talking about? Then you say, okay, who's just X? And this other guy is twice that, or is he 20 less than that, or what is it? Then you write that down. Let's do another one. Okay. Let's see. So everybody got that one there?
Yes.
Let's do something that's got 3 parts to it. Is he still going?
A little low.
Okay. There he is.